we have connected this transistor in NPN, common emitter. The transistor taken is NPN and connection is common emitter. First see here, we rotated it in such a way that emitter is downward. Now here emitter and base, they have forward biasing. Base is P, this is N, so NPN. So base and emitter P plus N minus. So this is forward biased. Collector N type, so it is connected with plus and this is with minus. So this collector is in reverse bias. Now we want to measure potential difference in this circuit. So we apply between base and emitter a voltmeter. This voltage we will call voltage between base and emitter, VBE. The battery gives a potential difference and that potential difference we will term as VBB. This is base battery. So the voltage of base battery is VBB, and what is this? This is the voltage applicable between B terminal and E terminal. So this is VBE. The current which is going through the base from plus going into the transistor, that will be known as current of the base, IB. The current which is coming out from the emitter, from here, the one which is coming out of the emitter is IE, and N, the current which is going in the collector, that will be current in collector. So this is how the arrows of current, B going in, plus 2 this way, N going in from this plus to N. Okay. Now we all know that this is the reverse current because plus is connected to N, right? So this current is coming out. If we apply Kirchhoff law here at this junction, this is the current approaching in, this is the current coming out. So we have an equation, IE is equal to IB plus IC. IB plus IC is equal to IE. That is beside the point. What we have to study here is, if we change this potential, what will be the change in this current? That gives us potential across base, changes in this potential and the changes in the current. If we make this study, that will be known as characteristic of the transistor. Which characteristic? This will be forward characteristic. Graph between VBE and IB. Now here this is another characteristic. This characteristic is between voltage between C and E and the current IC. So that will be known as reverse characteristic. This is forward, this is reverse. This forward characteristic is also known as input characteristic, and this reverse characteristic, okay, you understand, now it will be known as output characteristic. And here, which are the quantity which are changing with respect to each other? When we are changing VCE with help of this, when we are changing voltage between C and E, the current in this circuit will change. IC will change. So graph between voltage CE and current collector. This graph gives the reverse characteristic or output characteristic. Now, when we change this B to E, come to this circuit, the block diagram circuit. This is E, this is B, and this is our input circuit. B to E, and how much is this current? This is IB. What is the voltage between the two? This is VBE, this voltage, and this is the current flowing. Okay, this is plus, this is plus, this is minus, connected with N, so this is forward bias, and the current keeps on flowing. This current, when keeps on flowing, it is affected by what? It is affected by the concentration of positive charges here and negative charges here. At the same time, we find that this battery is also connected, and this is also sending a current here, and that is a reverse current. Reverse current means what? That current is not made by the majority charge carriers. Here the majority charge carriers are electrons, but electrons are not allowed to go along the electric field. So because of this field direction, because of the potential barrier, these majority charge carrier cannot go, but these minority charge carriers, the holes, they can very well go there, and they go on this side. When they come on this side, these holes are also there, and here is negative, so they very freely go there, so they are allowed to pass. Similarly, we can say the minority charge carrier here, which are electron, these are allowed to cross this electric field in this direction, and they go here. So electrons from here, holes from here, they form current here, and this current is reverse current. So that current is also flowing, and that current depends upon the potential difference here. When we increase this potential, what happens? When we increase this potential, number of the charges coming from there also increase. That means these positive also increase. When this holes coming here, positive charges increase here, then they also affect this current, because this current is affected, is counted by these holes. If this is sending these holes here, the number will increase and this current is affected. So you see, when we increase this voltage, the speed of these holes increase. When the speed of this hole increase, what we find? This is also sending its own holes, and we get this current as higher current than the scheduled current. This current increases because of this voltage. So this volt automatically increase, and because of that increase of potential, they push more electrons, so there are changes in electrons. There are changes in current, and we don't want to study that. Why? Because we are studying relation between VBE and IB. And if IB is affected by this current, IB is affected by this voltage, then this will not be our true reading. So what we should do? When we are studying the variation between the two quantities, all other quantities which may affect should be kept constant. Which is the other quantity which may affect? Our answer is this VCE between the two may affect this current. When this is sending more or less charges here, what we observe? This current change. So we should not allow this to change. So this we have to keep constant. And now we are ready to study the characteristic. So we make a table. in this table there are two things. One is VBE and IB, and here we write the reading of VCE which is kept constant, that we write here. We will not allow it to change. If it changes, how can we change this VCE and VBE? Answer by this. If we change this, VCE will change. If we change the rheostat here fitted with this battery, if we change the rheostat, VBE change. So we start changing this VBE and accordingly we keep on writing. So VBE we start from 0, 0.2, 0.4, 0.6, 0.8, 1, then 1.2, 1.4, 1.6, like this, and accordingly we see this. Here it is like this. Then so we make a graph. Every time we change VBE, anytime when we change VBE, we check the value of VCE. If it has changed, then by applying this, we bring it back to the normal, back to the original condition, so that we are sure that this area is not affecting our examination here. Okay. So we make this and then we draw the graph, and this graph you have already studied. This is a forward bias graph. So when you make this graph, it simply comes like this. So here we write that VCE is kept constant at particular voltage. Okay, that value we put here, and this is graph between what? IB and VBE. This is the graph, and you know, if we, what does it say? It says that at this value, this voltage is known as cut in voltage. Before that, there is no current in this circuit. After that, current start, and then that current increases. So this is forward bias. Initially no current, after cut in voltage, current starts, and that in increase in the right proportion. So this is forward biasing. The resistance in the forward biasing, resistance is few kilo ohm to few hundred kilo ohms. This is the dynamic resistance, and we have discussed how to find the dynamic resistance. At any particular voltage, this voltage, we will find the change in voltage divided by the change in current. That will give the slope, and that slope is equal to the resistance, dynamic resistance of input resistance. So this we call resistance input. So this is input circuit. Now we come to output circuit. For output circuit, we have to make the changes in VCE and observe the changes in current. So we will make a table. In this table, what will be the observation? Number 1, it will be VCE and IC. Okay. When we are doing this, first thing we observe that if we keep this IB 0, then there is no IC at all. Why there is no IC at all? Because these reverse current is formed when these minority charge carriers cross this and reach here. You know, earlier there were two depletion regions. This depletion region will allow it to pass the second one will not allowed. But by making it forward bias, we have already broken this. This side there is no depletion layer. Who has broken this? This circuit. So our first job is to start IB. To start IB. When voltage BE reach this point and IB start, what does that mean? This depletion layer has broken. And when this depletion layer has broken, then only these charges can go here. That means then only IC will start. Collector current will start only when this layer is broken, when IB has started. Before this, no. So we have to start IB, put it at certain value, and that we will write here. IB is equal to this much. But after that, we will not increase the value of IB, because if we increase the value of IB, that will get mixed up with this, and that will change the value of actual IC which is coming from here. We don't want it to change. So once we start it, suppose it is 4, we want that this 4 should always be 4. This should not be made 5 by this. This will come here, will be 5, and that fifth one will go here. The 2 will come here, make it 6, and 2 will go here. But if this is changes IB, then this will change and that change will go here, and that will change the value of IC. We don't want it to change. So what we will have to do? We will have to keep IB constant. Once we have done it, because we wanted to open the gate, gate has been opened. Now we don't want any support for IC, so IB is kept constant. Now we keep on changing it. Now we keep on changing it. This is 0, and then 1, 2, 3, 4, 5, 6 volt, like that. And now we see the current. The current goes on increasing, say microamperes, but it is 0, and then it is 1, 2, 3, 3, 3, 3, like that. Okay, so we make a graph. Why this has increased, this is not increasing? The answer is, when it was 0, it was 0, correct. When we make this voltage 1 volt, which voltage? This between the two, between this and this 1 volt, this one goes. When we make it 2 volt, then these 2 go. When we make it 3 volt, these 3 go with the pressure. When we make it 4 volt, there is no fourth. There is no fourth charge. So these 3 go. When we make it 5 volt, again these 3 go. When we make it 6 volt, again these 3 go. That means the current has become saturated. Now this current will not increase anymore. Such current is known as saturation current. And we are not allowing more holes to come from here. So this current cannot increase anymore. Okay, there can be another situation. What is that situation? Suppose these are 5, these are 3. This one comes here, replace this, this goes here, here goes. Current 1. Increase the voltage, these 2 come, push these 2, and this 2 will go here, current 2. Increase the voltage, 1, 2, 3 come, 1, 2, 3, they make line and they come forward. How much current? 3. 3 is the current. Now we increase the voltage to 4 and understand clearly. This 4 volt, push these 4, go, they go there. But here, this replace this, this replace this, this replace this, this has nothing to replace. Now how much will be the current here? Answer only 3. Now we make it 5. All the 5 come. But how many are there? 3. So only at a time 3 can go. Here the gate is open for 3. So only 3 can go. May there be thousands. Doesn't matter. Only 3 can go because this is allowing only 3 replacement. So 3 after 3 after 3. Yeah, they go like army. But how much is in one row? 3. So this current will be 3 and then 3 will be the saturation current. It will not increase. How can we increase that? It's very obvious. How can we increase that? Increase this current. If you increase this current, then this 3 will become 4. Now this current will increase. 4. If you increase that to 5, then this current will become 5. But we are not doing that when we are making the graph. We make it constant. Constant 3. So this will go up to 1, this will go up to 2, this will go up to 3, and after 3 it will not increase. How will be the graph now? The shape of graph. This is IC and this is VCE. So initially 0, 0. When we increase voltage, the current increase. When we increase voltage, current increase, and after that it does not increase. And we get a graph like this. This is the graph for VCE versus IC. Oh, this should be parallel. Okay. And this is the value of saturation current. IC saturation. We have to make a note that this saturation current is made when IB is so much. So here we write value of IB so much. Now suppose we change this. If we change this, then this current increase and this 3 become 4. Now again we make it. First 1 volt, 1 will go, then 2 will go, then 3 will go, and then 4 will go, because now we have made it 4. And after that there is no more here, so this 4, and it has increased up to this much. And here IB was here IB was 3 microampere, and here IB is 4 microampere. If I make it 6 microampere, then there are 1, 2, 3, 4, 5, 6. There will be a line of 6 after 6 after 6. And this current can go 1, 2, 3, 4, 5, 6. When we increase the voltage 1, 2, 3, 4, 5, 6. At this volt it will be 6 current. And we say it has increased like this, but after that saturated. So IB 3, 4, 5, 6. When IB is increased, the saturation current increase, and this gives what? The level of collector current, that is output current. This is inverse characteristic or outgoing output characteristic. Output characteristic, this is the graph for one characteristic, but if we change the value of IB, then IC saturation current change, initially will remain same, saturation will change, that is IC will change. So this is input characteristic, this is output characteristic. Please remember it. You have made this reverse bias characteristic in diode study. At that time we made it in the third quarter. Why we made it in the third quarter at that time? Because this quarter was busy for forward biasing. So reverse biasing we have shown here like this, because these two were to be compared, but now it is not there. We are making it a separate graph, so we can turn it anyway. So we have turned it here. So that hardly matters. What we should remember, that With change of Vc, Ic increase, becomes saturated, and this saturation current always depend upon Ib, how many these particles are supplied from this side. So this is transistor characteristic, and this is very important to understand the behavior of Ib and Ic, because this is going to help us to understand the next phenomena, that is amplification. So before amplification, we will see what are the different stages of transistor action, and after that we will see what is amplification. Here you have seen the current, here Ib is going, here Ic is going. So what is the total current? IE is equal to Ib, which is here, this is Ib, and this is Ic. So IE is equal to Ib plus Ic. IE is equal to Ib plus Ic. So this is what happens inside a transistor, and these are characteristics for NPN transistor in common emitter configuration. So in the next class we will see different stages and amplification done by transistor. Thank you.